Hello and welcome to another video. Today we're going to be doing repeated substring pattern. So in this problem, you're given a string and you're asked if it can be constructed by taking a substring of it and appending multiple copies of the substring together. So essentially in Python, you should be able to take some substring, like here, you would take AB and you would multiply it by 2 to get AB. So if there's something you can do like that, that is a valid substring. Also, they didn't show this in here, but something like AAA would also work. Right, so anything one character is also included. The substring length doesn't have to be 2. It can be 1 up to half the string because you have to multiply something by at least 2. So uppercase is half the string. And so ABA, you can't do that. And then ABC, 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 you can do that. And the constraints are 10 to the 4th, which honestly, looking at this problem in the beginning, I didn't think it was an easy problem. And I guess all the optimizations you can do definitely make it more of a medium problem. And even, I mean, I guess it's not really a hard problem because there's like tricks you can do, but those are like, I'm not really a huge fan of those solutions because it's like you either know the trick and it's like a one-liner, or you don't know the trick and you'll never come up with it. So not a huge fan of that. But anyway, the solution we're going to be focusing on is going to be like one that you probably would be expected to come up with in an interview question. So because this is an easy problem, we can go a little bit more in depth because it's not going to take us long. So what would be like our intuition for this brute force way of doing it? Well, what we can do is we can just take every character from 1 to the length of the substring over 2, right? So in this case, it would be like 1 to 2. We can just say like, okay, so 1 to 2, so 1, let's take this character, right? Let's say A. And how many times is that going to the string? So if we take like 1, our string length is 4. So we should be able to just take this first character, multiply it by 4, and we should be able to get AB. And if that's the case, then we found something. And so clearly here, this is not the case. So, but you could essentially build up strings with like A times 4, and then when it's 2, you take the first 2 characters and you figure out like how many times do I have to multiply that in to get the length of the string, right? And you do that every single time for every single number up to length of the string over 2, but you also have to make sure that like your number that you pick is your total is divisible by it, right? Like you wouldn't want to take something like 3 because you'd only want to pick numbers that 4 is divisible by. But yeah, you would just do that all the way up to, so I guess you wouldn't even have 3, but let's say your length is like 8 in this case. You would take 1 through 4, and you would only check numbers that are divisible, that 8 is divisible by, right? So you'd just pick like 1, 2, 4, 8 is divisible by those, and then you would take those substrings. So for like this ABC, 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 this is length 12, and then you would take, okay, like let's just take 1, so the first character is A, let's multiply that by 12. What do we get? Do we get ABC, ABC? No, we do not. So we move on. Then we take 2 characters. Is 12 divisible by that? Yes. So I'll just take AB, multiply by 6 this time. Do we get ABC, ABC, ABC? No, we do not. Then we have 3. So it goes into it 4 times. And what are the first 3 characters? ABC. Multiply it by 4. And you would get this. So that's essentially how you do it. And there's literally a button or like a way to write it in Python where you literally just multiply your string by whatever, construct a new string, and compare the strings for equality. So what would be the time and space for that one? Well, the time would obviously be O of, so if you're just looping through numbers like 1 to 4, it would be O of n to do that top loop. And then for the inner loop, you also have to construct the string, which would be O of n again. So that'd be O of n squared for time, and then you're constructing these inner strings. In worst case, your inner string is half of n, so that would be O of n space. And so we're going to try to get this down into something a little bit better, and we're going to do a few tricks here to do that. So for one thing, how do we loop through our numbers, but instead of going from 1 to, like, let's say our string is length 12, we don't want to loop from 1 to 6 in this outer loop. We want to loop something better. And so what can you do that's better? Well, it turns out, actually, what you can do is if you just loop from 1 to the square root of the number, lower bound. So what's the square root of 12? It's like 3 point something. So in this case, we would loop from 1 to 3. It turns out we can get every single number just from these. And let's take a look how. So for 1, we would say, okay, is 12 divisible by 1? Yes, it is. Well, what's 12 divided by 1? It's 12. So we can get both numbers that, like, 1 times something equals 12, right? So we can get both of those numbers. So 1 times 12. Okay, what about for 2? Is 12 divisible by 2? Yes, it is. Well, what's that, right? 2 times something is 12. It's 2 times what? It's 6. And then 3, is 12 divisible by 3? Yes, it is. So it's 3 and 4. And you see how we got every number that 12 is divisible by? And we only looked at these 3 numbers. We just said, let's just take 12 divided by these 3 numbers, and that'll give us the other number. So now we make our outer loop square root of n time complexity by doing that. Because essentially we would only have to check numbers from 1 to lower bound the square root of n. So that makes it better. Now we have these numbers, and these are all the possible lengths of these like substrings. So then how do we do these substrings? Well, we could, like I said before, we could just make substrings for all of these, right? So we could say, like, let's make a substring with a, let's multiply it by 12, and let's check that, and so on. But the problem with that is we're actually building substrings. So instead of building substrings, let's not build them. Let's just compare characters. Without actually building substring, that way our space can be O of 1. And so let's show what that means. So for example, for this ABA, let's say, or ABAB. So for this ABAB, let's say our string length is 1. We can just, like, so if the string length is 1, that means the string we care about is this string here, right? So we're going to compare the index of the current character on the string we're trying to compare to the index in the string. And the way that's going to look is we're going to loop through this outer string, right? So like we're going to loop through this, and we're going to say like, okay, we're over here in this outer string, and in the inner string we're only going to be in this character because this is a 1 character string. So we're going to compare this, and then we're going to move our character in the outer string, and we're going to compare A to B, and then that's not true, so we're going to break there. So that's false. But let's see what happens if our string, for example, is length 2 for ABAB, just to make it a little better. Okay, so for ABAB, our string length is 2 here. So once again, our top is going to compare this whole string, and our bottom is only going to loop through this first part. So it's going to go like here, and then it's going to go here, and then it's going to come back here. You'll essentially, like, your bottom thing you're comparing to will only be this string. So we're going to compare A to A. Is that true? Yes. Okay, we're moving both of those now. So let's move both of those. So now we're going to compare B to B. Is that true? Yes. Okay, now we're going to be moving both of them again. So this top one will keep going all the way down the string, but then this bottom one can't go past this word. So it'll just keep looping through this word. It'll go from here to the end and then back and so on. So is A equal to A? Yes, it is. Okay. And then finally, this last one is B equal to B. Yes, it is. And if you go through a word successfully, that means you did find a valid substring. So essentially, you'll have something like an index down here. It'll be something like, if this top thing, let's call this I, this will be like I mod the length of the string, right? So it'll be like I mod 2 or something like that, right? Because essentially what you want to do is you want to just have your bottom string only be at the length of your string. So if your length of the string is 4 characters, it's going to work the same kind of way, right? It'll just go like the index will be like here, then here, then here, then here, and then finally it loops back to the beginning. So you're never getting past that word. And it's pretty easy to do that in Python or any other language. Like let's say this is length 4. What you can just do is you can just say like I equals I plus 1 mod the length of the string, right? And so if you take a look, what that does is if it does that, I plus 1 mod the length of the string, like let's say this is index 3. So I plus 1 would be 4, and then we would mod 4, and it would be 0, right? So then we'd be back here again. So that's how you do that. So now we were able to, let's recap, we were able to get all these pairs in square root of n time in our outer loop, right? We're able to get all of these pairs. And we can also compare every character without actually making a substring by just saying, like, we know how long the substring is, so let's just loop through this whole top thing, and for this bottom, it's just going to be 2 pointers, and our bottom pointer will just keep going, like, back and forth. And if the whole string matches, then we have a truthful, like, we can return true, and if it doesn't, we just go on to the next word. And once we go through all of these, then we're guaranteed to have no solution. So that's essentially what we're doing. And there is one other thing. I'm going to quickly show it, but I'm not going to go into it, and it's something you probably wouldn't be able to come up with on your own if you haven't seen it before. But there is a trick, and this is the trick. So the trick is you can take your word, like ABAB, let's say, and you can multiply it by 2, so you get ABAB, ABAB. Now you get rid of the first and last character of your word, and now you can check if your original word was in that word. And so it wasn't here, so there is a solution. So if your original word was in that word, you have a solution, and if not, then you don't have a solution. So for like ABA, that would be ABA, ABA. We get rid of these 2 characters, and you can see there is no ABA in here. And so this works, and there's like a big proof behind it, but that's something you wouldn't be able to come up with, and that would be like a one-liner that runs in O of n time and O of n space. But our solution would be n square root of n with O of 1 space. And then that's the one that you'd be like most likely to come up with during an interview, so let's go through that for the code. Okay, let's actually make this bigger. Okay, so we're just gonna get, we want to get the length of our string, so let's do that first, because we're gonna reuse it, right? Okay, now remember, we can get all of the, we can get all of the lengths of possible strings by just looping through up to the square root of the length of it. So we can say for I in range, and the smallest length of a substring is going to be 1. So we could say, like, let's just do this, and let's do length like this to the half mod 2, or we need to get the lower bound, and we need to add 1. Because, like, let's say this is 1 to 2, this would actually only be 1 to 1, right? Because for a range loop, it doesn't include the last value, so we need to add 1 to make sure it includes everything. Okay, so now, if length mod I, this means that there is a remainder, right? So, like, let's say our length is 12 here, and our number we're trying is like 5. This would have a remainder. So if this is like true, that means there's a remainder, and that means our number can't go into the length. So we're not going to consider this to be a solution. So we just continue here. Okay. Now what we need to do is we need to get both of the numbers, right? We need to get both of the numbers. We need to get the divisor and the other number. So let's do that. So we're going to say for divisor in, and then we're going to have the two numbers. So the first number is I, right? We know I is valid. Like if our length is 12 and 12 mod 3 is 0, that means we know 3 is valid. But now we actually need to do 12 divided by 3 to get the other value. So let's do that. So let's get the other value, and it's going to be length divided by I. Now we have both of our values. And now we simply do this loop twice. So we could just say if, we also do want to check if divisor is length. So if our divisor is length, we don't want to use that, right? Like, for example, if we have string ABC, we don't want to use, so 1 is a valid string, but the 3 is not here, right? We don't want to use the whole word. We can't use the whole word. Okay, so we're going to have that check as well. So we're going to have if divisor equals length, that we don't want that check, so let's just continue there. Okay, now we're going to have a loop, and this is going to be in place with no substrings made. So for j in range, divisor length, right? We are starting, so if our word is like ABC, yeah, I forgot one thing, that's a slide optimization, but let's say our word is ABC, 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 and we're saying our substring is this, we don't actually have to look at the first few characters because we know like those are always going to be equal, right? Because those are going to be like the word. So we can check for characters after that divisor. And so that's why we are starting at the divisor. We don't need to check for these characters, we just need to check for this substring on the right to make sure that these characters are in here. We don't need to check this because obviously they're going to be the same because they are the same string. Okay, so I forgot to mention that, but yeah. So we can do this in place, and like I said, you can just do a mod. So if sj mod divisor does not equal the letter that we're currently at in the string, that means we can just break right now because that's not a solution. So this is going to check both of our numbers. And then finally, if it is true, then we can return true, right? So that's what we can do there. So we can say else, and let me just double check. Yeah, we can say else, return true. And now finally, we can have a return false, because assuming we went through our whole thing, we didn't find a solution, then we have no solution. Oh, and it looks like we need to probably convert this to an integer. So I think if we convert it to an integer, we don't need this. Yeah, because we have a half. Okay. It's a little windy right now because we actually have the hurricane. But yeah, so it actually doesn't show you that like it's super efficient, but it is actually efficient. It just has to do with like a LeetCode test, so it's kind of random. But yeah, it is space O of 1, and the time, like I said, if you do that trick where you take the string and you multiply by 2 and you check if your string is in there, that is going to be more efficient. So this is going to be time O of n square root of n and the space will be O of 1. Okay. So hopefully you like this problem. I think it's a good problem, a little bit tricky, but yeah. If you did like it, please like the video and subscribe to the channel. And I'll see you in the next one. Thanks for watching.